Well, in the ASTRE project, we only addressed part of the preservation problem. We only address the part which is related to signal processing, not the part related to the composition of the piece or the superstructure of the piece. Because there is an obvious mathematical formalism to describe the signal processing part, but not obvious. There are formalism, but no obvious formalism to describe the more compositional structure or the interactions at the composition level in the piece. So I think this is really one of the problems. Now, other problems are the fact that many pieces now use also specific hardware. For example, gesture controllers or sensors, and these are very specific. This sensor have real limits. So it means that the performer will learn how to play with these limits. So when it performs a piece, it performs with also specific sensors, and maybe these sensors have small defects, but the performer is able to use these defects. So how are you going to preserve that? So you need to preserve the sensors by themselves. So there is no absolute solution to the preservation. But having said that, I would say that it's not necessarily a problem. If we think of classical music made with scores and orchestra, the score doesn't tell everything about the music. Obviously, it's not the music, but it's an abstract description of the music. And this abstract description gives us the freedom to reinterpret the piece in a different way. So a piece of music is alive because it's interpreted and reinterpreted and reinterpreted. And this is because not everything is said into the score. The score have dimension for the freedom of the interpretation. So if we don't preserve everything, it's not a problem for me. We need just to preserve enough so that the piece continue to exist, but also to leave open the piece open to interpretation. So it's a balance that we need to figure out. We know that we can't preserve everything. As I say, it's difficult to preserve the sensors, for example. The compositional part is difficult. We need to solve that. But then, if we don't preserve everything, I don't think that as a major problem. But we need to preserve enough so that we can say that we have preserved that piece. It's a new interpretation, but then it will be still alive. So the interpretation question and the freedom of the interpretation, I think it's important for that. So as I said before, the suggestion, I would say, is to integrate the dimension of the preservation in the design of creative tools. So if we design our tools having in mind this question of preservation, being able to say formally what we are doing with this tool, then we solve a large part of the problem of preservation. We can generate automatically a description, a formal description of what we are doing with the software, so that we can re-implement that with a different software. So yes, it's a new it's a new thing that we have to have in mind. We have been used to design music programming languages for 30 years or 40 years or more. But now, and these programming languages were designed with the creation in mind. The idea to be to offer the composer a support for thinking about music. But now we need to invent formalism for the preservation. It's a little bit different. We need, because this formalism for preservation must be a formalism that evolves very slowly or very, very slowly. Formalism for creation can evolve very quickly, and composer will always wanted to use the latest version of any tool or any formalism, well, usually. But for preservation, then we need a different kind of temporal evolution for our tools. So it's a different way to think about formalism and formal system than for creation.